So we have been talking about all the scalability options in this series of webinars. In the first two webinars, we talked about what is the scalability challenge with most of the initial blockchains, the whole blockchain trilemma, where if you try to increase the security and decentralization, it's difficult to manage the scalability and vice versa. And how, different frameworks came into picture to solve the scalability issues, starting with Lightning Network on Bitcoin, to various like sharding and various other options. So we talked about all the different options in the webinar 1 and 2 of this series. Today, in this episode, we are solely focusing on the Appchains, which is not something very new, but more and more people are now getting into Appchains, considering what kind of challenges are there. So Appchains, called application-specific blockchains, as the name suggests, are your own custom blockchain where it's running one single app, your own app. And so you're not sharing the resources. You have your own custom blockchain. All the throughput is dedicated to your own application. And that is what the concept of Appchain is. Now, typically what happens is that there are two options today. So one is if you're building a DeFi app or an NFT app or any kind of decentralized application, you can use any of the layer ones or layer twos like Ethereum, Polygon, Avalanche, Solana to build your smart contracts, build your dApp and deploy on the virtual machine provided by the layer one, right? But in that case, what typically happens that you are competing with rest of the apps, the other apps which are deployed on the same virtual machine. So you are competing for resources. And since because of this competition, the gas fee is also not very predictable. The gas fee may change because gas fee typically is charged in the native token of the layer one, like ETH in the case of Ethereum or Matic in the case of Polygon. So as the congestion increases, as more apps are competing with each other for the same limited resources on the layer one, the gas price may jump. And we have seen quite a few instances in last 2-3 years where the price on Ethereum, sometimes went up to even thousands of dollars. So that is a challenge which, application-specific blockchains try to solve, where rather than depending on or building on directly on the VM-based blockchain, you are having your own application-specific blockchain. So what are the benefits of having Appchains? So one, of course, is scalability piece, because as I mentioned, you are not competing with resources with other apps on the ecosystem. So it's your own application-specific blockchain. You can achieve the complete throughput that is provided by the underlying blockchain. So that way, you can control the user experience, you can control the throughput, and achieve a decent scalability that is demanded by your application. The second piece is the whole gas fee. Now, in the case of application-specific blockchain, it is your own native token that is at the heart of it. And in most of the application Appchains frameworks, you can in fact have the gas fee being paid in your native token. So that way you control the gas fee also. And with configurations and some customizations, you can in fact fix the gas fee. Because there are quite a few enterprises who are looking at Appchains, and because that gives them an option to set up their own blockchain connected with the main chain, but at the same time control all kind of privacy, access controls, etc. So these kind of configurations, customizations can be easily done, where you can control the gas fee, you can control the consensus mechanism, you can control how different configurations are going to be there to achieve your whatever app you are building, the objectives of that. And third, I think, is most important piece is security. And to understand this, I think the important piece is that why app chain? Because app chains, typically you are using another blockchain to submit the transactions. So typically how it works. So for example, you take one of the app chain called Polygon supernets. So in Polygon supernet, what happens is it's your own app chain by creating a supernet, but then you batch the transactions and submit it on the main chain on Polygon or Ethereum. So why to do that? Because if you launch your own custom blockchain, the biggest challenge is to bring in your own validators, to bring in the desired security and decentralization. And that is where I think that is the core problem that app chains solve, where it lease or rent security and decentralization from the main chain. So you have your own blockchain, you control your configurations, you control your customizations, you have full scalability, you are not sharing resources with anyone. And as far as security and decentralization is concerned, that you are renting out from the main chain. So overall, it seems to be a very solid package where, you know, from day one, the day you launch, you are completely secured by the main chain, and yet you have a full control, your own custom blockchain. Now, just to, you know, take this further, I think it's fair to see how different options are there, and you know how they differ in different factors. So you will have a clarity on what a layer 1 blockchain is, what a layer 2, what side chains are, what app chains are. So and this is just a recap of what we you know, discussed in the last two webinars. So layer 1 blockchain is a fundamental, it's a base or a main chain that operates completely independently. It has got its own consensus mechanism. It brings in its own set of validators. So there's a huge onus on when you are launching your own layer 1 blockchain, there's a huge onus on not just bringing in the validator set, which are unknown to each other, but also you need to build a community and so on and so forth. Scalability, yes, when at the time of launch, of course, the layer 1 blockchain is quite scalable, but as more and more people start deploying their apps, and especially some of the apps which consume huge number of transactions like DeFi or gaming app, then scalability is suffers, because then it always becomes a choice whether to focus more on security and decentralization or focus on scalability. And then there would be a gas fee which needs to be paid in the native token of the layer 1. So if you are deploying your apps on Polygon, or you're deploying your apps on Avalanche or Ethereum, you're going to your app is going to use the gas fee to executing the smart contract transactions that will be paid in the native token of the layer 1 blockchain. And then, you know, interoperability, of course, because it's independent chain, so interoperability becomes limited. There are various ways, but those ways are not very robust in terms of providing interoperability with other layer 1 blockchains. So examples being Ethereum, Solana, Avalanche, Shardium, and so on and so forth. Then we had advent of layer 2 blockchains. And what layer 2 blockchain is, they try to solve the scalability challenges of layer 1. So, and the whole idea of layer 2, as we discussed in the last webinar, was that there's a scalability challenge on layer 1, and layer 2 blockchain, basically, they work like an independent blockchain, but then all the transactions are being pooled and then submitted on layer 1. And there are various ways we discussed about layer 2. So there are optimistic rollups, where Optimism and Arbitrum are leading players. And then we have ZK rollups, where, you know, Polygon ZK AVM, which launched its mainnet beta in March this year. And then we have ZK Sync. We have quite a few other layer 2 blockchains now. Linea is one of the latest blockchain being launched by consensus, again ZK based layer 2 blockchain on Ethereum. So layer 2 blockchain, you know, relies on security of the underlying layer 1 blockchain, but it improves the scalability because these are processing transactions on layer 2 and then submitting those transactions on the main chain. So that way it reduces the scalability challenges on layer 1 and provides much more scalability to different apps they are deploying. But fundamentally, if you see, end of the day, layer 2 blockchain are also blockchains. And when they grow, then users start feeling that scalability challenges on the layer 2 itself, like what has happened. So when Polygon came in, it solved the scalability challenges of Ethereum to a large extent, very low gas fee, faster transactions throughput, finality, etc. But now as Polygon has grown massively in last 2-3 years, now we are seeing congestion happening on layer 2 itself. So that definitely is going to be there, and it connects with the layer 1, interoperable with other layer 2 solutions depending on how it has been architected. And as we, as I mentioned, there are optimistic rollups like Optimism, Arbitrum. There are ZK based layer 2s like Polygon, ZK AVM, or ZK Sync, etc. Then at the same time, that there was a concept of side chains. We discussed that in detail, what the side chains are. The side chains again are very similar to layer 2s. They are a separate blockchain who are linked to the main chain, and there's a clear interoperability where data transfer, asset transfer can happen between the side chain and the main chain. If you see, Lisk is one of the example which started side chains, and then Polygon POS itself, the main Polygon chain today, it's again a side chain to Ethereum. And they again act as a independent blockchain, like they have independent consensus mechanism. They're all separate operations, and they provide again scalability like layer 2 blockchains to the layer 1. Now vis-a-vis this layer 1 and layer 2's / side chains, if you compare Appchains are your own customized blockchain, which is app specific. It's only your application which is running. So there are quite a few. In fact, today I was reading one news about Palm Network, which is now moving on to Appchain infrastructure. So there are quite a few larger applications, enterprise applications. Enterprises are looking at it, and then quite a few startups who are launching big, or they have already become big. They are looking at app chains to reduce gas fee, to have their own custom blockchain with custom set of configurations. And app chains rely on the parent chain or the main chain for the security mechanism. So if you see Avalon subnets, for example, the main chain validators validate on the Avalon subnet. So if you create a subnet, it's your own custom blockchain, and the validation or the consensus is being run by the validators on the main chain. And you can have your own native token. The gas fee again can be paid in your own native token rather than the native token of the main chain. And it can be interoperable. It is definitely interoperable with the main chain, but then it can be interoperable with other app chains within the same ecosystem. Some of the examples, and we'll discuss in detail about these examples, being like Substrate parachains or Avalon subnet or Polygon supernets, BNB side chains, and then there are quite a few other layer 1s who are now coming up with app chains. These are just some names, but today Optimism has launched super chains, and then Tezos has launched its own smart chains, which are again rollups. You can build your own app chain using those rollups. So most of the layer 1 protocols are now coming up with the app chain infrastructure, so that people can build application specific blockchains on their network. Now, if you want to create your own blockchain, there are primarily 3 options. One option is you can fork an existing blockchain, like you can fork Ethereum and create your own custom blockchain, or fork Lisk or any other blockchain platform. And this has been there for quite some time, but there are lots and lots of challenges in doing that, because one, the customization, etc., takes a lot of efforts, because when you are using a protocol that has been designed with a certain reason, and you are launching your own blockchain with certain other objectives, it becomes very difficult to match it. Since they have not been designed as a framework, it's difficult to understand the code structure if you want to make customization. If you are launching a plain vanilla blockchain, then also it takes a lot of efforts to bring in all validators and so on and so forth. So the other 2 options are better options. So the second option is using blockchain frameworks. So two primary frameworks which are very popular in the market. Hundreds of blockchains have been built on them. One is the Cosmos SDK and the second is Substrate by Polkadot as part of the Polkadot ecosystem. So in fact, if you see, Cosmos and Polkadot both were created as a network of networks or Internet of Chains. These were some of the names that were used when they launched. And the whole idea was that there is one main network, and then using the framework you can create n number of different blockchains with interoperability natively supported with the main chain as well as within the different ecosystems. So and as any development framework, they provide ready set of plugins and modules that you can put together and create your own custom blockchain. And at the same time, you can create your own set of modules. You can customize the existing open source modules. So that gives lots and lots of flexibility to launch your own blockchain. We'll talk about quite a few examples, but as I mentioned, hundreds of blockchains have been built using Cosmos and Substrate. So these are very well established frameworks for creating your own custom blockchain. And you can create a general purpose blockchain also, like if you see Moonbeam, which is a parachain built on Substrate and also supports EVM. Is a full-fledged blockchain. It has its own ecosystem. Hundreds and thousands of dApps have been deployed on Moonbeam. Similarly, there are chains like Corium or Osmosis, which are built on Cosmos SDK, and they can be complete full-fledged blockchain like Provenance blockchain, focused on enterprise. They are built using Cosmos SDK. And then third, which is primarily we are talking about here, is the creating your own app chain using subnets or supernets and similar app chain infrastructure like rollups, optimistic rollups, or different kind of ZK rollups. So you can create your own application specific blockchain. So second and third are, second is something which has already been there for almost last 4 or 5 years, and many blockchains have been built using that. And Appchains is something, the third is something which has picked up in last 1 year and is something which is right now latest, and most of the layer ones are launching their own frameworks. So this I think I have already discussed about forking. There are a lot of security challenges because you need to set up your own validator set, you need to set up your own community. It's like you have to do everything from scratch as what that specific layer one did in its own time. And at the same time, customization, configurations, etc. becomes very difficult because the underlying blockchain that you forked was not designed as a framework. And I think as a developer, you would be able to appreciate the difference between these two. Because once somebody creates a project for launching a project, the modularity over a period of time suffers. There may not be proper documentation to understand the underlying code. So if you, for example, fork Bitcoin or Ethereum and want to create your own blockchain, if you want to launch a plain vanilla, it still works. But if you want to do any kind of customization, it becomes a very big challenge. And then, getting traction, etc. Again, you're competing in the layer one space, which is well studded with lots and lots of players, and some of them have become humongous. So second option, as we talked about, Cosmos SDK and Substrate. So these are our proper frameworks, and we have been used to using frameworks in the Web2 space also. So we know that when you use a framework, there are ready components, there are ready plugins, modules that can be bring together. And there are a lot of community contributed plugins, maybe free or paid. So over a period of time, there is a plugin and module marketplace which you can leverage and you can combine. And in the initial set of modules itself are sufficient to set up your own blockchain. So they are much better as compared to forking a blockchain, because you have a lot of ready plugins. There's a well-defined documentation, so it becomes easy for you to navigate the underlying code and how the things are structured. There's a lot of configurability that is there. And then, since it is framework based, the whole network management, infrastructure management becomes more predictable, much easier to maintain also. So, and then, within the network, there's a clear interoperability. Like in the case of Cosmos, if you create a Cosmos SDK based chain, it has got a module called IBC. Using IBC, you can interoperate with other Cosmos chains. So there are a lot of these native components. They have a Tendermint based consensus mechanism that again you can use. So, and then plus at the same time it's modular, so you can choose to have other consensus if you want. So it gives a lot of flexibility also. So first talking in this category, talking about Cosmos SDK. So as I mentioned, was launched as the Internet of Blockchains, where you have Cosmos SDK to spin off your own blockchain with that Tendermint consensus mechanisms. And these app chains are called zones, and they connect to the main chain, and they are also connecting with other zones or other app chains. And I strictly would not use the word app chains here, because using Cosmos SDK, you can create a custom blockchain also, where you can invite other people to build their dApps and deploy. For example, Corium is a blockchain in itself using Cosmos SDK. So it is interoperable with other Cosmos chains like Osmosis, etc., and interoperable with the main Cosmos chain. But at the same time, you can it has got a full-fledged VM, and you can deploy your own smart contracts. You can build different kind of enterprise applications, tokenizations, etc., using that. And since it is open source, gives a lot of flexibility of the choice of consensus. You can have one of the interesting piece here is that you can create your own flavor, because it's your own custom blockchain. So you can create a flavor where you want to have permissioning to completely public or somewhere in between, where you have some features which are permissioned, some features which are public. So you can do that, and that's true not just for the frameworks, but also true for app chains. Some of the examples, as I mentioned, DYDX is the one of the latest project. It's a very large decentralized exchange, one of the largest, has been there. Now they are recently, decided to move to their own chain using Cosmos SDK, and it has got off-chain order book, matching engine, and DYDX is the native token of the app chain, and they bring in their own validators, and you can pay the gas fee in their native token DYDX. Similarly, Osmosis is quite a seasoned player, has been there with Osmosis, with Cosmos for quite some time, and it's again is the original largest DEX on the Cosmos ecosystem, and allows you all the decentralized exchange features like swapping, earning, building, etc. It's a POS network. It has its own native token called Osmo. And then Corium, that is one of our partners, and we have been providing infrastructure for Corium, quite a few validators, as well as RPC, and working with a lot of projects which are being built on Corium. So Corium is a layer 1 blockchain, which is focused on real world asset tokenization. It has been promoted by Sologenic, which has been there in the asset tokenization space for last 3-4 years. And Corium was launched, the main mainnet was launched in March this year, and it has been growing very rapidly. It has been built using Cosmos SDK, but as I mentioned, it's not specifically an app chain, but more of a focused on a certain use case like tokenization of real world assets. But on Corium, anyone can come in and deploy their own applications also. Now, the second option in the second category is Substrate. Substrate, I think, is again, like Cosmos, very popular framework. When Polkadot was launched, Polkadot again was launched as Internet of Blockchains or Network of Networks. And the whole idea was that Polkadot network, like you do not deploy dApps on Polkadot. You always create parachains or parathreads to run smart contracts and run decentralized applications. And then these parachains and parathreads, they are connected with the Polkadot main chain. So that is how, and to create these parachains, there is a blockchain framework called Substrate. So you use Substrate to spin off your own blockchain, and it gives you an independence. So you can run it as an independent blockchain built using Substrate, or you can connect it with the with Polkadot in the form of a parachain. So not all substrate-based blockchains are parachains, but yeah, parachains are all substrate-based. So substrate again is highly modular. There are huge number of components, and there are very few, quite a few interesting innovations that substrate brought around. One is runtime upgrades. So you can actually upgrade or update quite a few pieces while the blockchain is still running. It's called forkless updates. So you don't require a hard fork to do an update. That was a very cool innovation as compared to the earlier blockchains, where some of the changes may require a hard fork to be done. And the way Substrate was designed, it's highly composable, and at the same time, updates and upgrades can be happen in the runtime. It provides a very modular and flexible framework. So again, like Cosmos, it has got a lot of modules, and there are palettes. So there's a concept of palettes. So palette is something which has got a specific set of features and functionality. In fact, like you take an example of, there are quite a few parachains where they have added the support of EVM. The Substrate is typically Rust based, and it's a non-EVM chain or VM. So you can add the EVM functionality as a palette. So palette is like a module which encompasses a certain set of features. You can define your own palette. There are a lot of existing open source palettes as part of the Substrate ecosystem, but based on your use case, you can create your own palette. So there's a complete documentation how to build your own custom palette. And as I mentioned, there's a library of modules that you can choose, and you can customize to a very large extent. Very different set of blockchains have been built on Substrate. Hundreds of blockchains have been. There are almost 190 plus parachains itself, like Substrate-based chains which are connected to the Polkadot main chain. And apart from that, there are hundreds of other blockchains which are not parachains, are independently operating as a Substrate-based chains. Some of the examples of Substrate-based chains, like Akala, it's a DeFi hub for the Polkadot network. Akala is one of the parachains and quite popular. And then there is Aster and Fala network. So quite a few parachains are there. We have been working with quite a few parachains, providing infrastructure like Humidify, some of the new Substrate-based parachains. And then Moonbeam, Moonriver, as I mentioned, is a complete blockchain in itself, operating as a parachain to Polkadot, and it supports both Rust, which is the native to Substrate, but also provides EVM compatibility. And that's a very interesting project, has been in the market for more than 2 years now. Very popular parachain built on the Substrate. Now let's come to the third category, which is the Appchains, as we call them. So, which are powered by the layer 1s or layer 2s like Ethereum. So as I mentioned, these are application-specific blockchains, typically used to run one single application. So a lot of enterprises who are, launching their blockchain-based application, they're typically single application, and they require a lot of customizations and configurations to match compliances or security, or their unique set of configurations, permissioning, etc. Our Appchains become a preferred choice. So, enterprises have been building on some of the earlier permission blockchains like Hyperledger Fabric or Besu or R3 Coda, etc. So Appchains are now offering alternative to those initial frameworks. And since Appchains get connected, lend security and decentralization from the main chain, that is one reason why Appchains are being more preferred option as compared to the earlier permission blockchains. Because in the case of earlier permission blockchains, if you're launching your own network, but you're not able to bring in other enterprises or other stakeholders to come and host their own nodes. One of the challenge in earlier blockchain frameworks was that, fabric-based networks, etc., the decentralization was lacking, or it was not sufficiently decentralized. Appchains solve that because you do not need to go the hard way to bring in validators and make the chain more decentralized. But you can lend decentralization, you can lease decentralization from the main chain. So first, let's talk about Avalanche Subnet. So we'll talk about Avalanche Subnet and Polygon Supernets, two most prominent app chain players in the market today. And of course, as I mentioned, most of the layer ones are now, a lot of different app chains are coming in, built on different layer one, whether it be Tezos, whether it be Near. So everyone is coming up with their own app chains. So in the Avalanche, it's called subnet. So everyone has given their own names to app chains. So app chains is more of a general term which defines application-specific blockchains, but each layer 1 blockchain or layer 2 blockchain has given their own names to it. So in the Avalanche, it's called Avalanche Subnets. And as I mentioned, it's your own custom blockchain. So it's your own network where you define your own rules, own configurations, own native token, your own token economics. And in the case of Avalanche, the main chain validators, like 4 or 5 validators, main chain validators, has to validate on your subnet, or your subnet validators have to validate on the main chain. So that way you're leasing security and decentralization from the Avalanche main chain. And each blockchain is validated by exactly one subnet, while a subnet can validate many blockchains. And some of the benefits of using Avalanche subnet is, one, there is no limit on the number of subnets that can be created. Like in the case of Polkadot parachains, there's a limit on number of parachains. There's a restriction. There's a proper auctioning and a process to become a parachain. And that too, you get a parachain auction slot for only a specific period of time. Vis-a-vis that, Avalanche subnet does not have any limit on the number of subnets that can be created. And the transaction processing time, the finality time is 1 to 2 seconds. And it has got a very high throughput, 4,500 transaction per second or even more. And so just imagine you're launching your own custom blockchain. You have got a 4,500 TPS as a throughput. Pretty much you can run any kind of app, including your financial app or gaming app or any other DeFi app, without facing challenges on the scalability side. Some of the examples, I've covered 2 examples that we have been working with. One is Remedy, a healthcare platform based out of US. It's a very sophisticated healthcare platform which provides complete clinical systems management as well as patient healthcare data, providing resiliency, security, and secured sharing of the data. It is built on Avalanche as a subnet, and the extensive set of features that Remedy platform has shows that how much flexibility and customization can be done. And one interesting thing in the case of Remedy, it was running on another blockchain platform and migrated to subnets. The second is Meld, a DeFi protocol and a Web3 bank. It's a non-custodial DeFi protocol for Web3 finance, and in fact, they are launching a whole Web3 bank. One of the most interesting piece of Meld is that they are, bringing together the fiat ecosystem and the crypto ecosystem. So, and that is something that is very much required today if we want to see more adoption of cryptocurrencies across the ecosystem. And then there are quite a few, quite a few subnets that are being there. And a lot of newer players are now, as I mentioned, quite a few enterprises who are operating on some previous systems are migrating to subnets and supernets. Now, the second most prominent is Polygon Supernet. Polygon Supernet has got 2 flavors. Like, Polygon, there are 2 chains now in the market. The most popular chain that we know Polygon for is the Polygon POS chain, which is a side chain, as we discussed, on Ethereum. And then in this March, Polygon also launched ZK AVM Supernet. So ZK AVM is ZK rollup based chain, but also has got a full native EVM support. And they launched this as in March. So now there are 2 chains right now. And so when Polygon launched Supernet, the initial Supernets were based on POS chain called Polygon POS Supernet. And now after the ZK EVM was launched, Polygon has launched Polygon ZK EVM Supernet also. And Polygon ZK EVM Supernet is getting a lot of traction. It is something new right now, but has got amazing throughput, finality time. It's very fast, using ZK as a cryptographic proofs, and all the transactions are being submitted on Ethereum in a batch kind of process. And it has got a native bridge to connect with the root chain, and plus you have your own set of transactions. And we in the last webinar we discussed about the architecture of a supernet, but here we are just talking about what supernets provide. So there's a whole implementation partner program. There are a lot of implementation partners. Zeeve is in fact one of the leading infrastructure implementation partner for Polygon Supernets, and we have been working with quite a few projects today who are building on Polygon Supernet. And as I mentioned, it is based on ZK. The earlier Supernet was based on POS, and there's a huge scalability, very solid finality time. Gas fee is something within your control. Some of the examples being, Genesis Pay and then Outer Life. I would not like to name some of the customers because those are right now being launched. The public launch is anticipated in August. So I've not mentioned those names, but yeah, supernets are like, subnets. They are picking up very well. There are hundreds of projects now who are already started building on Supernet. So yeah, it's a very exciting new offering that is there in the market. Then there's a BNB application side chain. So very similar to what we discussed about Avalanche and Polygon. So BNB also has launched its side chains, and again, the concept is very similar. It's your own custom blockchain. You can configure, you can customize, you have your own native token, you can control your gas fee. And again, you can either stake on the main chain, or you can run your own validator nodes to secure a side chain, or onboard a third-party validator who is already working on the main chain. So very similar to what we discussed about subnets. And some of the BNB application side chains are like Antimatter V2 or MetaApps games, and then there are quite a few other side chains which are built. So Binance already has got a very robust and strong ecosystem of apps, and quite a few of those apps, and that's the trend we are seeing. Some of the existing large apps which were launched in last 2 years, 3 years, and have grown bigger, has got huge number of transactions or user base. They are, I think, the first who are adopting the Appchains, because there's an easy move. The migration is not that difficult, and in fact, Zeeve, one of the solid expertise we have is, migrating chain, including the data migration, including the state migration from one chain to another. So that is something that we see, and quite a few early adopters are basically apps which have already been running. And at the same time, a lot of new players, whether building dApps or enterprises building blockchain-based applications, they are looking at Appchains to migrate there. And then, as I mentioned, there are quite a few other like Tezos, Starknet. So lots and lots of players are like optimistic super chains, which have been lost by optimism. So everyone is now launching their own app chains. One, it is makes easy for their existing dApps as part of their ecosystem to move to their own app chain infrastructure whenever they feel challenges related to congestion or configurations or customizability or scalability, etc. So yeah, so I think this is all which I wanted to cover here. So Zeeve is the leading provider in the world for app chain infrastructure as a service, or rollups as a service. And we have, in fact, automated the entire process so that you can actually spin off your own custom blockchain, which used to take months and months in just few minutes to an hour. And if you even require a lot of customizations, configurations, we have a very solid expert team of almost 130 people to help you with migrating your data state if you have been running an existing chain, or if you are building from scratch, make it so easy and so cost effective that and everything is based on a pay-as-you-go model. So there's very limited one-time build-up cost that gets involved only when there's a very relationship-specific customization or project-specific customization. So we provide all the necessary components. So launching your app chain, launching your blockchain does not involve just deploying nodes, because when you're launching your own blockchain, you require your own explorer, you require your own testnet faucets, you require cross-chain plugins, you require your own validator infrastructure, your own data indexing protocol, so that your smart contract data can be queried or analytical dashboards can be built on top of them. So you require different components to launch a custom blockchain. And way we have designed the whole app chain infrastructure as a service makes it so simple, so easy, so that you can focus on building your dApp, getting more users, building your community, rather than worrying about the underlying infrastructure. So that's for today. Thanks everyone. Since we have time, I can take any questions you have. If you have any questions, you can put on the Q&A section, and I'll be more than happy to answer any of your questions. So if there are no questions, I hope you have enjoyed this webinar. And okay, I see one question. Yeah, so one question is, could we use subgraphs? So yeah, you're absolutely right. We have in fact extended the support of subgraphs. I'm assuming Viraj, that you are asking about Appchains. So we have extended the support of subgraphs as well as subquery. These are two most popular platforms today for querying smart contract data. We have extended the support of subgraphs as well as subquery to both subnets and supernets. Ashok, which application framework should be best? So yeah, so for lower budget MVP, I would say Appchains is something which cuts down huge amount of cost, because you're leasing quite a few things from the main chain, and rest of the components are well built. And since you are doing an MVP, my assumption is there would not be a lot of customizations. So that way, I think Appchains, Polygon Supernet, or Avalon Subnet becomes a very good option. Which industry-specific enterprises? So I would not say industry-specific, I would say more or use case-specific, right? So let's say, and any use case that people were building on permission blockchain, like, using Hyperledger Fabric or Sawtooth or Besu or R3 Coda, they were all application-specific networks, right? In fact, all your consortiums, they were all based on a specific use case in an industry, like supply chain track and trace, for example, or commodity tokenization, or trading and settlement in the exchanges. So all these kind of use cases that have been built using their own custom network, using Fabric, etc. The same can be done using Appchains. So you can build pretty much any use case. See, the point is that you are building an application, right? It can be any use case, any industry. Now there are choice. So as in Web2, we have a choice, right? We have a shared hosting, we have a dedicated hosting, right? In shared hosting, you are sharing resources with other people. So when you are launching a small website, 4 or 5 pages website, typically what we used to do, we used to take a shared hosting space. Why to pay more? We used to take just hosting from GoDaddy or HostGator or someone else, right? But when you are launching a bigger application, then you require a proper cloud environment, your own dedicated infrastructure, where you want to have RDS, a managed database. You require load balancing so that your network, your infrastructure doesn't go down, or your applications don't suffer, right? So you require dedicated infrastructure. You're not sharing with other shared resources. Similarly here, any app that you build, you can deploy on Ethereum or Polygon or Avalanche. But if you think that your app requires dedicated resources and you don't want to share it with other people, you want to have a predictable gas fee, you want to have your own set of configurations, you want to have a mix of some configurations or permissions and some openness as public. So you can have all these options, right? So these kind of apps, you would prefer Appchains. Ashok, related to real estate tokenization. So see, real estate tokenization is already happening. We have few customers out of US and Australia who are doing pretty good on real estate tokenization. And I think, see, the real world asset tokenization, I have, conducted several webinars on this topic. And personally, I have been very bullish and optimistic about the asset tokenization space. The only thing right now, which is a deterrent in the short run, maybe another 6 months, year or 2 years, that is the whole compliances and regulation piece. Once, there are proper regulations, proper compliances to tokenize assets, and then, launch the whole primary marketplace, secondary marketplace, etc. There is going to be a huge boom in this space. And suddenly you will see there would be, I would say, thousands and thousands of projects are right now waiting on the sidelines to launch real world asset tokenization. That involves your digital assets like bonds, etc., or real estate or carbon credits, or, all kind of different kind of assets. So yeah, so this is something which is very promising. Once you are able to solve or resort to a jurisdiction where there are some regulations that you can use, I think this is going to be very successful. Is analytics summaries? Yes. So now in the case of Deepak, in the case of analytics summaries, one is that using subgraph, we provide indexing protocol for different blockchains. So that means indexing protocol is when you index data, including the custom smart contract data, into a off-chain database. And on top of it, we have built a layer of APIs through which you can query that data. So there are some plain vanilla APIs for for straightforward plain vanilla queries. But for your custom queries, you typically create your own subgraph, right? Because you want to pick and choose based on your own smart contract that what kind of data points would be there, what kind of data you require. So then using subgraph, you create your own custom set of APIs. So yes, we do provide the end-to-end piece for subgraphs and subquery. And on top of it, you can, once we expose the data using your custom APIs, you can build your analytical dashboard on top of it. So it can be analytical summary or dashboard, full-fledged dashboard. Ashok, our company name is Zeeve. Sorry, I forgot to introduce myself. My name is Ravi. I'm the co-founder, CEO of Zeeve. Zeeve is one of the leading blockchain infrastructure as a service platform in the world. We have 27,000 plus Web3 startups and 30 plus large enterprises who are using our platform to manage the blockchain infrastructure. So we provide shared APIs, we provide dedicated nodes, whether it be RPC nodes, archive nodes, validator nodes. We provide deployment of complete blockchain infrastructure, whether it be Hyperledger Fabric or Besu or R3 Coda or Polygon supernets or Avalanche subnets. And we are adding more and more options now. And we are a no-code platform, so you can deploy nodes and get shared APIs on the fly, do it yourself. And if there are any customizations, we have a very strong team of 130 plus people who can help you with any of your app chain or infrastructure requirement. So I hope I have answered all your queries. Still, if you have any queries, do connect with us over Twitter, LinkedIn, or Telegram. You can connect with me also on LinkedIn. I'm very active on LinkedIn. So if you have any questions, you can connect me on LinkedIn and we can always talk about it. You can, if you require any technical support, if you want to know about our services, you can always go on our website, zeeve.io. You can use our talk to an expert form and schedule a call, or you can use our chat to talk with our tech team or the sales team in real time. Thank you. Thanks everyone. It has been wonderful having you all here. Thanks for your time today.